Hello, good afternoon, everyone. Thank you very much for being here today. This is Panta Rei's webinar number 8. We will be talking about brine and water recovery systems. Thank you very much for being here today. We will wait for a couple of minutes because we see that some people are writing to us. They are in the waiting room or they are writing that they are going to be here shortly. So we'll be starting in a couple of minutes. This will be the last webinar of this series. As you know, we started this series back in April when the lockdown measures started in many of the countries. So we started with the lockdown measures, and then we went on to talk about several aspects related to the water and wastewater treatment. Thank you for being here with us during all this stage, during all this lockdown period, and now during these challenging times. But we are sure that everything is going to be okay somehow. And thanks again for being here with us and for having followed us during this way with the webinars. So we will start our presentation now. For those of us who maybe were not present in previous presentations, just a very quick information about us. We are an Italian company. We're focused on the water and wastewater treatment for the textile industries. We are present basically in all continents. And we have been in the market since the very beginning in the textile aspects, in the textile field. So this is our area of expertise. We are an ISO certified company, and we're also part of the Zero Discharge of Hazardous Chemicals program, which many of you may know already. We have a common goal of guaranteeing clean discharges, and we have gone through this, let's say, milestone-wise program, which is comprised by the foundational, progressive and aspirational guidelines that we have explained also in our past webinars. And this is a road that we're walking along with many of the factories and with many of the brands together. We have more than 90 working effluent treatment plants. More than 65 are located in Southeast Asia, and we have a capillary network of agents. So for any specific request, our agents will be happy to follow it. We have been present in this market for 12 years. Actually, in 4 days, we'll be 13 years old. And since the beginning, we have been focused on the textile industry. So this is a webinar schedule. As you can see, as we mentioned before, this is the last webinar of the series. But if any of you is interested in the previous webinars, starting next week, they will be all available, also this one, in our website. Seminars from 1 to 5 are already online in our webpage, www.pantareiwater.com. If you go to the research and development page, you will be able to find the link to the videos of all the webinars. We started all with the lockdown measures, then we went on to talk about the fluff removal, the biological process, ETP equipment maintenance, zero discharge of hazardous chemicals, MBR, sludge treatment, and finally, what is closing this series is the water and brine recovery systems. So we're going to talk about wastewater treatment plants because you know that we always try to offer some environmentally friendly solutions. And this is the reason why the biological treatment has become basically our flagship. The main component, the main milestone of the wastewater treatment that will allow us to go to the water recovery. I would really like to emphasize this because a good water recovery starts with a good pretreatment. And in this case, the pretreatment for the water recovery is normally a biological section in order to stabilize all the biological matter or the organic matter. So we think about recovery in a very global manner, in a cradle-to-grave approach. That means anything that comes in order to see what comes out. So we think about the output reflecting on the input. So this is the reason why when we talk about a water recycling process, we also think about what's the best approach to get to this goal. In this case, we can talk about effluent separation, effluent differentiation. Why? Because we have in many cases the dye bath, and we have the washings, the rinses, and they have different characteristics. So whenever it's possible, we recommend to separate these effluents because the dye bath may contain up to 70% of the color and salts that are being used in the whole process. So it's a very concentrated effluent. So if we can tackle this at the beginning, then we can also improve the quality of the water recovery and reduce the costs. Of course, we are well aware that it's not always possible to do this. We are well aware that in some factories, it's not possible to separate the effluents anymore, or maybe that it's not possible to have sodium chloride as salt. But don't worry, because we have alternative solutions for everyone. As we mentioned, we have a worldwide network of agents. So we always do a very customized, a personalized solutions to our customers. So whenever you need any water recovery project, you can count on us and we will give you an alternative solution. So talking about the brine recovery, well, the brine recovery system is focused on the dye bath, especially in the dye baths, which are mostly made up of sodium chloride salt. And with this treatment, we're able to give a solution with an economic advantage, which recovers this brine, recovers this effluent in terms of a clear brine containing nothing but the salt and water. And we can recover up to 70% of the dye bath contents. That means that up to 75% of the salt that you are buying in order to do your dyeing process can be recovered back into the process already in liquid form. As you may already know, the dye bath has a high pH, a high temperature, and a high salt concentration. So it cannot be treated with any other kind of system, because if we use this for a biological system, that means that basically all the microorganisms will be killed if we put such a high pH and temperature inside, because we can achieve pH values of up to 13 and temperature values of up to 70 or even 80 in some cases degrees Celsius. That of course would kill any bacteria and microorganisms present. Plus we have a significant amount of suspended solids as well. So what do? We do a first step, which is a fine screening, and then we remove the fluff, the excessive suspended solids, with a microfiltration system. And then we have the membrane treatment, which is the core of the treatment. The first step is an ultrafiltration in order to remove all suspended solids. Since we are talking about a very concentrated effluent, very hot, and an effluent with very high pH, then we use ultrafiltration, but it's not a common ultrafiltration made out of polymeric material. It's a ceramic ultrafiltration, which can withstand any high temperature, any high pH values without any problem. And once we have treated the effluent with this ultrafiltration system, we can go into the next step in order to think about really the color removal and the recovery of the brine. So we have to neutralize and cool down the solution, because in order to remove the color, we're going to have to apply a nanofiltration system. In order to use this kind of membranes, we need to neutralize the effluent to make it pH neutral, and we have to cool it down because the maximum operating temperature in nanofiltration membranes is 40 degrees more or less. So we will cool it down to around 35 degrees Celsius and then go into the nanofiltration step. This nanofiltration step will completely remove the color, and then we will have a clear brine which can be reused back into the process. We can show you here a case study. Basically, this was the result of a dye bath having an average of 30,000 units of platinum cobalt in terms of color. So it's a highly concentrated effluent. And the outlet value after this brine recovery system was just 52 units of platinum cobalt. This means a 99.8% of color removal. In the pictures that you can see in this slide, you can see what the inlet water looked like. It was the dark concentrated solution that you can see on the left. Then the intermediate passage is an orange solution basically. And then the final result is made by this transparent final effluent, which you can see on the right. The amount of sodium chloride that was contained was 60 grams per liter, and it was kept basically at the same level up to 58 grams per liter of salt at the outlet. So the effluent on the right, which is the clear brine, is what you would get back after the treatment. You can see that the salt is perfectly diluted in this clean water, and you can reuse it back into the process. So this is about brine recovery, but now we will talk about the water recovery. And one thing that we would like to stress is that we can do both, or we can do one of those according to your needs. So in this case, if we have separated the flows, we will have the dye bath and the rest will be the rinses. And those would this would go to the water recovery system. When we put the brine recovery system before, that means that you have the chance to lower the operating costs of the reverse osmosis, because if you decrease the TDS, so if you decrease the salt that is going into the reverse osmosis, you decrease also the osmotic pressure. That means less energy, so less cost in order to pump that water through the RO. So one thing that we also want to stress is that we do not consider the zero discharge to be the only approach for water recovery. We are well aware that it requires a significant amount of energy. And we know that saline byproduct is generated, and it can be needed to evaporate it, for example, or it can be subject to further treatments in order to properly take care of it. But we can offer alternative solutions. For example, we can treat only maybe 20 to 40% of the water coming out of the biological treatment. That means that you treat a part of the water and the rejection is able still to meet the discharge parameters. So even the RO concentrate, when mixed with the other outlet of the biological process, can still meet the discharge limits, and you would be able to recover 20 to 40% of the water to use it back into your process. We can certainly propose a zero discharge solution. And normally this is an approach that we can do, especially when the water cost is high, or in some places that it's required by law. For example, we have had experiences in India in the past, where in some Indian states, it was mandated that no water could come out of the factory. So in those cases, there was no choice, basically. Or also in some other regions where there was almost no fresh water available. So we must recover the water completely in that case. In other cases, we can adjust according to the situation that each customer is in. So for the water recovery, we will be talking about getting the water that comes out of the secondary treatment, in this case, a biological treatment, So after we have properly stabilized all the organic matter, that means that we have reduced the BOD and the COD to an acceptable level for the membrane treatment, then we can go into this water recovery. Normally, this water recovery is made out of fine filtration, ultrafiltration, and reverse osmosis stages. So the first step for the water recovery will be the fine filtration. Normally, you can do that with a sand filter, of course, but we have alternative solutions, which are more, let's say, plug-and-play solutions that can allow you to operate 24/7 without stopping. Why? Because we propose these filters which continuously work and backwash continuously without stopping the machine, so you do not need large storage tanks to feed the filtration unit, and you guarantee a continuous water delivery into the ultrafiltration system, which is the next step. Here we're talking about stainless steel filters with a 20 micron filtration grade. So it's a very fine filtration that can be achieved in a very compact unit and with a very limited space requirement. After the fine filtration, we have the ultrafiltration system. It means that we are going to filter the water so that the suspended solids are blocked and they do not go into the reverse osmosis. This is a pretreatment. It improves the performance and the lifespan of the reverse osmosis membranes because it acts as a shield to the system, a shield to the reverse osmosis. This ultrafiltration system has a filtration range from 0.1 to 0.01 microns. And it's suitable for basically any kind of application after a biological treatment. So, and finally, after the ultrafiltration, we have the water recovery. This is the ultimate filtration treatment. As you know, it's the only one that's able to separate the dissolved salts from the rest of the water. And it can give you an effluent with even less than 150 milligrams per liter of salt. So, without requiring further treatment, this water coming out of the reverse osmosis can be used back into the system. It can be used back into the production because we can use the water wherever we need an application of high quality water. That means water without hardness, water without high TDS, water without color. And of course, it will be without any organic matter residuals. We have also developed pilot plants for the water recovery. They can be installed at some existing facilities, always after a biological treatment. And this allows us to achieve results that are completely satisfactory in order to reuse the water. Now we will use the results of a case study regarding the quality of the recovered water. So here you can see, for example, the inlet BODs that we had after a biological treatment was 22 and it was less than 3. COD was 125 and the final result was less than 5 milligrams per liter. The inlet TDS value was 3,500 milligrams per liter, and at the outlet we got just 47 milligrams per liter of TDS. So as you can see, this is even better than the groundwater that was used at the inlet by this specific company. The hardness was 9 milligrams per liter, and at the end it was just 0.02. Chlorides went down from 940 to 8, and sulfates went down from 1,280 to 5. So the color value, another very important thing, was less than 5 units of platinum cobalt. So basically colorless water. We can see some pictures here. We can see the inlet to the water recovery system. What you see there at the leftmost picture, the leftmost glass, is the water coming out of the clarifier without use of the colorant. So this is why you see still a significant amount of color. Why the colorant wasn't used? Well, because of course, if you use a water recovery system, you do not need to use the colorant here because it will be removed by the reverse osmosis. The center sample that you see, the center glass, is the outlet of the ultrafiltration system. This is also the same water quality that can be seen after an MBR treatment. So ultrafiltration or MBR basically give you the same kind of effluent results. And finally, on the far right, you can see the sample with the RO water, which is completely transparent water that can be reused back into the process. So here we have closed all the, let's say of the circle. And basically, we started with the lockdown measures, we went to the treatments, we went to the biological treatment, and finally, we are here, the last step, which is the water recovery. So thank you very much for watching this presentation. We can see a couple of questions here on the chat. For those who are attending the webinar for the first time, please note that it will be made available online in our website. It's www.pantareiwebinar.com, and it will be in the research and development section. I will write down the page here, pantareiwebinar.com. Please go to research and development. And there you will be able to see the past presentations up to webinar number 5 are already online. Webinars 6, 7, and 8 will be made available starting from next week. And of course, if you have any specific questions, you can go to our agents also. We can see some other questions about the quality of ultrafiltration, and also the comparison with other technologies with like ion exchange resins or sun filters. Of course, you cannot compare sun filters with water recovery with reverse osmosis because they are completely different technologies. For color removal technologies, you can use nanofiltration, RO, and of course there are some exchange resins, ion exchange resins, which can remove the color, but we have seen that the operating costs are much higher, and also the initial cost, the capital costs are higher because the resins then need to be regenerated and they change after some time. So we have seen that this is not really feasible in order to make it an economically sustainable option. After the UF, of course, you can improve the color by using RO. So the RO, we will improve the color value after the ultrafiltration because the RO will remove the color. About the operational cost, well, this is something that we can discuss if you approach our agents, because we can tell you for your specific treatment plan what it is, because of course each customer has a different kind of effluent, so different salinity, different values of VOD, COD, different values after the current biological treatment will have different operational costs in the treatment. The watercolor of the reject of the DRO, of course, it will not comply with the standards. As we mentioned before in this presentation, we make it so that if you recover a large percentage, of course, you will have a more concentrated effluent, but what will happen? That we can treat the or reject maybe with a small mechanical physical treatment in order to remove the color and make it compliant. This, yes, can be done. And some of our customers who are located near the sea, for example, since they are compliant, the RO reject is compliant with the BOD and COD and TSS limits. When we remove the color, it will be also compliant with the color. And even if it has high salinity, of course, being by the sea will mean that they are allowed to discharge a high salinity anyway. We see a very interesting question about the polyaluminum chloride used in the wastewater. And of course, now you have a high volume of RO in the feed. That's because, of course, because the polyaluminum chloride is used at the ETP. This is actually also the reason why we use to use organic decolorants before the discharge, so that we do not increase the metal amount or the TDS value. And if you are going to water recovery, you just don't use the decolorant. But of course, if you use any aluminum-based coagulants, if you use any iron-based coagulants, you will for sure have these metals also in the outlet. So the brine color will be removed. Yes, it will be removed through the nanofiltration section. Of course, as we mentioned in this presentation, you have ultrafiltration with ceramic membranes for the brine, and then nanofiltration for the color removal. We have one question. If you don't want to use, but still want to achieve similar color, well, if you don't want to use RO and achieve similar color at the outlet, the only way is to use a lot of the colorants, of course, but you will generate a lot of sludge and the cost will be very high. The impact of pH in RO scaling and how pH can control this deposition. This is very interesting because, of course, there will be a pH control in the system in order to make sure that there is no scaling in the RO, and also that the pH is controlled at the outlet. And in any case, we already consider the use of anti-scalant agent in the RO section. This anti-scalant is also used for nanofiltration. How impurities will be removed from the salt? This is a very good question. The impurities will be removed from the salt through the ultrafiltration and nanofiltration treatment, because in the nanofiltration you will be removing the impurities also due to organic residual salts, organic to residual solids will be removed by the nanofiltration section. The recommended coagulant instead of PAC, you have MBR and RO for recycling. Well, since you are using MBR and RO, our recommendation would be just do not use the coagulant there. You can use the coagulant to remove the color of the RO concentrate, but you can avoid the use of the colorant at this step. And if you were going to use the colorant, you can use organic-based decolorants instead of iron-based coagulants. Because when you mean coagulant, for us that means that the colorant agent, right? The one that you're using in order to remove the color. So thank you very much for the questions that we have received. Once again, if you have any specific question, you can always approach our local agents. We have local agents in all Southeast Asia and also in the American continents. So whenever you have any question, you can always go to our webpage, www.pantreiwebinar.com. If you do not need who the area agent is on our webpage, you will be able to see the list of agents that we have worldwide, and they will be happy to get back to you, or you can also drop us an email. You will see our email contacts online, and we will redirect you to the right agent for your zone. So thank you very much for your attention. Thank you for being here today. You will find the webinar presentations on our website, www.pantreiwebinar.com, on the Research and Development zone. In that area, On that section, you will find the presentations, you will find the past presentations, and also from next week, you will be able to see this presentation. Thank you very much, everyone, for being here today. Stay safe, and thanks again on behalf of all the Panta Rei staff. Thank you very much. Bye-bye.